Okay, so here's my pulse width modulation experiment using a 10 watt LED. This LED is over here on the right. It's mounted on the heat sink. There's also some wires for a fan. This happens to be a cooler fan, but we're not going to use the fan. The heat sink's enough. So this 10 watt LED operates from 9 to 12 volts. I got it from electronic Goldmine. Here's what it looks like. And it's $6 on electronic Goldmine. It's pretty bright. I use it for a desk lamp, which is what this circuit here is I designed for. So this is a PIC device. I programmed it in C++. And it does pulse width modulation depending upon how many times you touch this wire right here. So this wire is a touch sensor that's programmed. I've programmed it to PIC, and you can attach that wire to like a doorknob or a strip of sticky copper foil or whatever you want. In this case, I'm just touching the wire. So I have an oscilloscope hooked up to it. That's this right here. That's going to the gate of the FET. This is the FET. You can barely see it. It's an SMD FET. It's rated at 20 volts max, 2.5 amps source to drain current. And I picked it because it's extremely small, and the gate voltage is only 2 volts. Trigger it. So I'm running this PIC at 3.3, so it's a perfect gate voltage for it. And this white wire right here this is coming from the PIC, and that's driving the gate. So if you take a look at the oscilloscope right now, you can see a pulse width. So on times are very short right now. I have the PIC programmed for 4 steps. Touching the touch wire, so I'm going to touch the wire, and it goes up to the next level, and then full on, and then one more touch will turn it off. So that's how the device works, and it is driving the FET, which in turn is connected up to the 10 watt LED. So I'm going to move the LED back over to the drain. Right, the source is grounded on the FET, and then we're driving the gate with pulses. So now as I touch it the first time, and we're also running 12 volts into this. So I touch it the first time, you'll see the LED lights up. It's very bright, so I'm going to turn it to the side. So this is at the minimum pulse width. You can see on the oscilloscope. So also what I have here is my trusty fluke, and attached to that fluke is this fluke temperature sensor. So I've had that for many years. Right now you can see the ambient temperature is 76 degrees, 76.8. So now what I'm going to do is, and remember, this is at minimum pulse. I'm going to touch the probe to the case of the MosFET. It's kind of hard to do. So I'm going to touch it and hold it there for a little bit. And you can see on the gauge, it's come up like a few tenths of a degrees. Not much. Slowly coming up. Not much. So now I'm going to touch the touch wire again, go up to the next level. You can see the brightness increased. Still touching it. And it's coming up. Yeah, a few more tenths. We'll just let it sit here for a few seconds. So you can see it's still dissipating virtually zero. So I'm going to touch the wire again, going to a higher level. So you can see it's at a higher level now, it's brighter. Continue touching the probe to the SMD. And we're looking at the meter. And we've come up to 81 degrees. It's still very touchable with the finger. And we'll let it sit there for a little while. Now this particular MosFET, I believe, is a BSS 806N. It's an SMD, and it has an on resistance of 57 milliohms, so extremely small on resistance. So there's going to be very, very little dissipation. Although the SMD device can dissipate up to half watt. Alright, so let's go full on. Touch it one more time. You can see it got brighter, and now it's full on. Now the LED is drawing about an amp now. That's what it's rated for. Looks like it's going to stabilize at 87, around 87 and a half. So that's the experiment. Let's turn this bugger off, okay? The point is, I'm going to touch it just so you can see it's not even hot. It's barely lukewarm. The point is to show you that the switching element dissipation is extremely using MOSFETs and pulse width modulation, controlling a rather large LED. That's it.